Jai Shri Krishna, Mitro. So, in hydrocarbons, last time we can discuss about the preparation, chemical properties, physical properties of alkene. Now we can start the third point. First we can discuss about the alkane, then alkene. Now here in this lecture we can discuss about the alkynes. Here we can discuss about the alkynes. Clear? First of all, alkyne is an unsaturated hydrocarbon, no doubt. Because it can have triple bond. Alkyne is an unsaturated hydrocarbon because it can have at least one triple bond. Triple bond means that if we can specify it, first one is sigma, then pi, and then pi. One sigma bond and two pi bonds are there. Therefore, you can say that it is a unsaturated hydrocarbon. First of all, the compound which should be considered as alkyne is contain at least one triple bond. If we can have any compound and it can have at least one triple bond, then we can say that it is alkyne. Clear? The simplest member of alkyne is C triple bond C, H and H, which is acetylene. The common name is acetylene and the IUPAC name is, we know that, ethyne. Clear? Which is a very important member, and nowadays it is very useful in oxyacetylene flame. It is useful in oxyacetylene flame, and this oxyacetylene flame is used to weld or in the welding purpose. If we can have a metal rod, iron rod, we can weld it, we can combine it, so we can use some material, and with this we can use some flame, which flame is known as oxyacetylene flame, which is generated with the help of acetylene gas, and it is used to weld the ions or metals. Clear? So it is a use. It is the simplest member. Then other ones are CH3, C, triple bond CH. Clear? And homologous series are there. So here we can say that the IUPAC nomenclature and whatever we can discuss in the last lectures. Here we can say that if any compound which can have at least one triple bond, say, therefore we can say that it is an alkyne. Clear? Alkynes are of the two types. Suppose we can have alkynes like that: CH3, C triple bond CH3, and CH3 CH. Both are alkyne. But if triple bonds are present on the terminal or on the end, whatever, left side end or right side end, it is known as terminal alkyne. Alkynes. It is non-terminal alkynes. Generally, terminal alkynes are acidic. Generally, terminal alkynes are acidic, which we can discuss in the chemical properties, but you can remember that alkynes is of the two types: terminal alkynes and non-terminal alkyne. Terminal alkynes means the triple bond is present on the end of the any side, right side or left side. Now we can discuss about the structure of alkyne. Isomerism and IUPAC nomenclature are discussed in the previous lectures, so here we cannot discuss it. Structure of alkyne. Suppose here we can take simple example: C triple bond C, H and H, acetylene or ethyne. Now, if you can draw the structure, electronic structure of, or orbital structure of this molecule, this is a carbon, this is a carbon. These two carbons are make a one sigma bond with the partnership of electron, and one sigma bond with hydrogen. It is a p orbital of carbon. It is hydrogen. It is also sigma bond and sigma bond. And these bond angles are 180 degree. These bond angles are 180 degree. Clear? So we can say that it is a linear structure. It is a linear structure. Bond angles are 180 degree. मतलब straight line में है bonding. Now remaining p orbitals of carbon. Now there are 4 valence electrons in the carbon, valence shell of carbon. एक वस्तु याद रखજો કે કાર્બનની વેલેન્સ શેલની અંદર 4 ઇલેક્ટ્રોન એમાં એને 2 યુઝ કરી નાખ્યા સિગ્મા બોન્ડિંગની અંદર. હજી એની આગળ 2 ઇલેક્ટ્રોન્સ બોન્ડિંગ માટે અવેલેબલ છે. તો હવે કેવી રીતના બોન્ડિંગ કરશે? નાવ ધારો કે આ એક પ્લેન હતું. It is a one plane. Now this carbon, here a carbon, here hydrogen and hydrogen. These are the sigma bonding. Now 2 p orbitals are perpendicular to the plane or perpendicular to the each other. Suppose if we can have a 1 p is a second p, it is a 1 p, it is a second p. Clear? So याद रखो कि now 2 p orbitals of carbon are available for bonding. One electron is in this lobe and one electron is in this lobe. Here also one and also one. Now these are made to combine pi bonding. હવે એકબીજા સાથે કમ્બાઈન થઈ અને પાઈ બોન્ડિંગ કરશે, બરાબર? તો શું થશે? તો કે એક પાઈ બોન્ડ અહીંયા ક્રિએટ થશે આ અને એક પાઈ બોન્ડ અહીંયા ક્રિએટ થશે. યસ, these two lobes are perpendicular to each other and perpendicular to plane also. And if anyone can ask what is the symmetry of this molecule, you can say that cylindrical. It can have a cylindrical symmetry. Cylindrical symmetry means it is like cylinder, straight, but the orbitals of pi bond is throughout the molecule, means round about the molecule. Clear? So it is a structure of alkyne which you can discuss here. Clear? जो आनी अंदर एक मेन पॉइंट आ जाए तो कि सिलिंड्रिकल सिमेट्री है, लीनियर स्ट्रक्चर है, 180 डिग्री बॉन्ड एंगल है, बराबर? नाउ दिस बोथ कार्बन हैज sp hybridization. This both carbon which contain a triple bond have sp hybridization. Clear? આખી વાત સમજાય કે આ જે પ્લેન છે એ પ્લેનને પરપેન્ડિક્યુલર પાઈ ઓર્બિટલ છે અને એક છે એ આ બાજુ છે. બે જે પી ઓર્બિટલ્સ છે પાઈ બોન્ડિંગ છે એ પ્લેનને તો પરપેન્ડિક્યુલર છે જ, પણ ઈચ અધર પણ પરપેન્ડિક્યુલર છે. એક પી ઓર્બિટલ આવી રીતના છે તો એક પી ઓર્બિટલ આવી રીતના છે, પણ એ પી ઓર્બિટલ આપણે અહીંયા ડ્રો કરી શકતા નથી, જેથી કરીને આપણે એને સહેજ આવી રીતના બતાવી છે. ક્લિયર? સો ઇટ ઇઝ વેરી સિમ્પલ. સિલિન્ડ્રિકલ સિમેટ્રી મીન્સ it is goes through the linearly and around the all around the single bond. Single bond ની અરાઉન્ડ માં પાઈ બોન્ડિંગ નું ક્લાઉડ છે અને એ સ્ટ્રેટ લાઇન માં ફેલાયેલું છે. ક્લિયર? સિલિન્ડ્રિકલ સિમેટ્રી છે. Now we can discuss about the preparation methods of alkyne. Now we can discuss about the preparation methods of alkyne. Now we can discuss about the preparation methods of alkyne. In this first method is dehydrohalogenation of dihalides, generally vicinal dihalides. Clear? And we can discuss here dehydrohalogenation of dihalides, generally we can use here vicinal dihalides. Suppose if we can have the reaction like that, by heating ethylene bromide, here ethylene bromide or ethylidene bromide with alcoholic KOH followed by sodamide, means NaNH2 in liquid ammonia, to gives acetylene. Suppose carbon, hydrogen, hydrogen, bromine, hydrogen, bromine, hydrogen, 1,2-dibromo ethane, 1,2-dibromo ethane. We can treat it with alcoholic KOH, then here H and Br are released. અહીંયાથી HBr release થઈ જાય. We can get a double bond here and we can have a molecule like that. Further, if we can follow it with strong reducing agent NaNH2 in the presence of liquid ammonia at 196 Kelvin, then further here HBr is released and triple bond is created and we can get the product ethyne. It is a very simple method. Yes. તમે આની અંદર આલ્કોહોલિક KOH ની જગ્યાએ બોથ ટાઈમ સોડામાઇડ પણ યુઝ કરી શકો. સોડામાઇડ NaNH2 એન્ડ લિક્વિડ એમોનિયા કેન બી યુઝડ ઇન્સ્ટેડ ઓફ આલ્કોહોલિક KOH. આલ્કોહોલિક KOH ની જગ્યાએ સોડામાઇડ યુઝ કર્યું હોય તો પણ સેમ રિએક્શન જ થાય. અહીંયા પણ તમે સોડામાઇડ યુઝ કરી શકો. ક્લિયર? સો હિયર આપણે એક જનરલ રિએક્શન બતાવી કે RCBrH CHBrH 2 times we can use sodamide in the presence of liquid ammonia and 196 Kelvin temperature. Then we can get directly RC triple bond CH. In first step this is released, and second step these two are released, and we can get the triple bond between these two carbon, and the side product are 2NaBr and 2NH3. 2NaBr and 2NH3. Clear? So it is the first method, very important method to synthesize the alkynes from dihalides, generally vicinal dihalides. Yes, in some books geminal dihalides માંથી પણ પ્રિપેરેશન બતાવી છે, પણ આપણે તો ટેક્સ્ટ બુક મુજબ જાય તો વિસિનલ મુજબ જ પ્રિપેરેશન કરશું. નેક્સ્ટ, by heating 1122 tetrachloroethane with zinc in methanol. 1122 tetrachloromethane with zinc in methanol. We can heat this molecule with zinc in the presence of any alcohol like methanol. We can get here a triple bond alkyne acetylene, and ZnCl2 is a side product. Next method which we can discuss here, we can remember it. Third method, by heating haloform. Haloform means CHX3. જો અહીંયા ક્લોરીન હોય તો ક્લોરોફોર્મ, ફ્લોરિન હોય તો ફ્લોરોફોર્મ, બ્રોમિન હોય તો બ્રોમોફોર્મ, આયોડિન હોય તો આયોડોફોર્મ. ક્લિયર? આપણે આ તો જોઈએ છીએ CHCl3, આપણે એને ક્લોરોફોર્મ કહીએ. બ્રોમિન હોય તો બ્રોમોફોર્મ. ફ્લોરિન જનરલી યુઝ કરતો આવું પ્રિપેર કરતો નથી, બરાબર? અને આયોડિન તો આયોડોફોર્મ. સપોઝ હિયર વી કેન બાય હીટિંગ હેલોફોર્મ વિથ સિલ્વર પાવડર. Suppose we can have a iodoform CHI3. We can have a 2 molecules of CHI3, and we can heat with silver powder. Then here I and Ag as released as AgI, and we can get this part combined to give alkynes. Clear? So generally it is the very costly method because we can use here a silver, but in some exams ક્યારેક જો આપણને પૂછાય છે કે હેલોફોર્મ્સની સિલ્વર પાવડર સાથે રિએક્શનથી શું મળશે, તો આપણે કહી શકીએ કે વી કેન ગેટ અ alkyne acetylene. Clear? Now next methods are, the method is by the electrolysis of aqueous solution of sodium or potassium malate or fumarate. In general it is a coal-based electrolysis method. In general it is a coal-based electrolysis method which we can discuss, but here we can discuss here or memorize it. By the electrolysis of aqueous solution of sodium or potassium salt of malate or fumarate. Clear? Or coal-based electrolysis method. Suppose here CH double bond CH, C double OK, C double OK, potassium malate, C isomer, potassium malate, C isomer. Barabar? Now we can get hydrolysis or electrolysis in the presence of water to get first ethyne to CO2 plus H2 plus 2 KOH. It is a general reaction which you can discuss also in the coal-based electrolysis method. What is the mechanism? First, this salt is ionized to give CHCOO minus, CHCOO minus and 2K plus, and water is ionized to give 2OH minus and 2H plus. Why 2? Because here 2 electrons are released in the oxidation. Now oxidations occur on the anode. હવે ઓક્સિડેશન કોનું થશે તો કે this species get oxidized. આની આગળ પણ 2 ઇલેક્ટ્રોન છે, આની આગળ પણ 2 ઇલેક્ટ્રોન છે, બેમાંથી એક એક ઇલેક્ટ્રોન રિલીઝ થશે. Here you can get 2 electron and this, and it can have a radical. Now it is unstable. અહીંયાથી આણે એક ઇલેક્ટ્રોન રિલીઝ કર્યો, એક ઇલેક્ટ્રોન અહીંયાથી ડોનેટ કર્યો, ઓક્સિડેશન થયું. ક્લિયર? It can get oxidized to give this unstable species. Yes, અહીંયા હું -2 ઇલેક્ટ્રોન લખું છું, and these unstable species rearrange to give ethyne plus 2 CO2. એ કેવી રીતના રીઅરેન્જ થાય આપણે કોલ-બેઝ ઇલેક્ટ્રોલિસિસ મેથડની અંદર ડિસ્કસ કર્યું છે. ક્લિયર? એન્ડ at the cathode H plus gets reduced to give H2 because 2 electrons are released here, so 2 electrons are used in the reduction process, and 2H plus are 2H plus જે ionized ફોર્મમાં હતા reduce થઈને H2 gas મળશે. Clear? So it is a very simple method to synthesize the alkynes. Next one is laboratory method. In laboratory generally acetylene gas is obtain with the help of calcium carbide and treatment of calcium carbide with water. If we can have a CaC2 calcium carbide, if we can treat it with water, we can get acetylene plus CaOH twice. Yes, remember it, it is a laboratory method. Laboratory માં આપણે ક્યારે એસિટિલિનની જરૂર પડે, ઇન્સ્ટન્ટ આપણે એસિટિલિન કે પ્રિપેર કરવો હોય તો we can prepare it with the help of calcium carbide and water. Other methods which we can discuss here, in this first method is from limestone. It is industrial methods. Generally we can synthesize acetylene or alkynes in large scale with the help of these methods. If we can have a limestone, calcium carbonate, CaCO3, we can heat in the some specific boiler at 2275 Kelvin temperature. Now we can obtain CaO and CO2. This CaO is treated with carbon at the same temperature to give CaC2 and CO. Now this CaC2 is hydrolyzed with the help of water to give acetylene and CaOH twice. If anyone can say that from limestone we can get alkynes or acetylene, yes, we can obtain it with the help of this method. Clear? But we can heat very high temperature. Second is, acetylene is manufactured by heating methane or natural gas at 1773 Kelvin in an electrical arc. मतलब we can have a methane or natural gas because the natural gas નું main container methane है. એને આપણે electrical arc આપીએ અને એને કેટલા temperature heat કરીએ, how temperature we can heat it, 1773 Kelvin, then we can get acetylene and hydrogen. Clear? Next one is, now recent days this method is used to prepare the acetylene. Methane and oxygen 1773 Kelvin એને હીટ કરશું, ઓક્સિડાઇઝ થશે, we can get CH triple bond CH plus carbon monoxide plus 10 times H2. Recent nowadays we can prepare the acetylene with the help of this method. Next method, magnesium carbide. If we can have Mg2C3 magnesium carbide, we can hydrolyze it with the help of water. We can get CH3 C triple bond CH, not acetylene. It is a prop 1 ion plus MgOH twice. And last one method, which is Berthelot synthesis. It is this. Berthelot synthesis is this. We can have carbon, we can reduce with the help of hydrogen at a 3000 Kelvin to get acetylene, CH triple bond CH. So here we can discuss some preparation methods of alkynes, and in our syllabus 2 methods are given. We can discuss other method also, and here we can finish the preparation methods of alkyne. Now if we can think about the physical properties of alkyne, it is like that. Now we can discuss about the physical properties of alkynes, which we can remember it. There is no concepts. First, the first 3 members means C2, C3 and C4, 2 carbon, 3 carbon and 4 carbon containing members are colorless gas. The next 8 are liquid while higher ones are solid. First 3 member means C2, C3, C4 are colorless gas. Next 8 liquids and higher ones are solid. Clear? Which you can remember. Acetylene has a garlic odor due to the presence of phosphine as an impurity. In the acetylene gas, phosphine is an impurity, and this phosphine contain a garlic like smell, લસણ જેવી smell. બરાબર? તો acetylene has a garlic like odor due to the presence of phosphine as an impurity. Clear? Next one, alkynes are weakly polar. Lighter than water means water કરતા એની density ઓછી હોય, lighter than water. Immiscible with water मतलब immiscible मतलब there is no we cannot dissolve the alkynes in water, insoluble in water, but highly soluble in organic solvents like ether, acetone, benzene, CCl4. Alkynes are weakly polar, there is no polarity. Weakly polar है, lighter than water, insoluble in water, but highly soluble in organic solvents like this. Next one is, the melting and boiling points of alkynes are slightly higher than those of corresponding members of alkane and alkyne series. Suppose we can have a carbon containing alkane and alkene and 3 carbon containing alkyne, then melting point and boiling points of alkynes are higher than alkene and alkene. Sorry, alkynes, alkene, alkane. It can have a 3 carbon, it can have a 3 carbon, it can have a 3 carbon. If you can compare melting point and boiling point, then the higher ones are in the alkynes, then alkene and alkane. Clear? What is the reason for that? The reason for that is, this is due to the fact that alkynes have a linear structure. Linear structure to chhe alkynes ne, and therefore their molecules are rather more closely packed in the crystal lattice as compared to alkanes and alkene. Alkane and alkenes ની અંદર જે ક્લોઝ પેકિંગ હોય મોલેક્યુલ્સનું, એના કરતાં વધારે ક્લોઝ પેક હોય આ ક્રિસ્ટલ લેટાઇસની અંદર. ક્રિસ્ટલ લેટાઇસ મીન્સ ઇટ ઇઝ અ પર્ટિક્યુલર પાર્ટ ઓફ any molecule or one system to arrange the molecules in the bulky or large quantity. Clear? Large quantity માં મોલેક્યુલ એકબીજાની સાથે કેવી રીતના અરેન્જ થાય છે અને ક્રિસ્ટલ લેટાઇસ કહેવાય, જે which you can study in the solid state. Now next one is, their melting point, boiling point and density increases in molecular mass. If we can compare the melting point, boiling point and density in the alkyne series, then molecular mass increases, density, melting point, boiling point increases through the alkynes. So it is the physical properties of alkyne, which you can remember. In next lecture we can discuss the chemical properties and chemical reactivities of alkyne. So preparation, structure, common introduction and physical properties which you can discuss in this lecture. તો આજના માટે આટલું મિત્રો, વધારે next time.